Deliver faster, lower-risk integration projects with WSO2's technologies for open-source API management, enterprise integration, and identity management. All delivered using WSO2's integration methodology for agility. Learn more at wso2.com.
Hello and welcome to the InfoQ podcast. My name is Wes Rice and I'm the co-host of the podcast. I also chair a set of software conferences called QCon. Today on the podcast, we're talking to co-founder and chief technologist of Camunda, an open source software company reinventing workflow automation. We're going to be talking to Bernd Rucker specifically about event-driven architectures, events. We're going to talk about the difference between events, commands. We're going to talk about CQRS. We're going to talk about a variety of things. So, Bernd, welcome to the InfoQ podcast.
Thanks for having me.
So let's start off and tell us about Camunda. What does Camunda do?
So we're basically a software vendor providing open source workflow automation platform or workflow engine, if you like. We're roughly 140 people based in or headquartered in Germany, but we also have a lot of people in the US on the ground at the moment. We're acting globally with that. And if I say workflow automation, most people normally don't think of necessarily, let's say, sexy things. But I find that very interesting. I'm doing that basically all my life. And I think there are two things around that which are very often surprising to people. So one is like workflow automation has a lot of use cases, which are not the classical, let's say, human task management or tasks lists or end-to-end business processes. So there are a lot of very technical use cases, actually. So we probably can tackle that a bit later on, which I find very interesting. And the other thing is we, from the beginning, tackled that as kind of a bottom-up approach. So we have a platform, we say that's very developer-friendly. So it hooks into the developer world. It's not about low code. It's not about like business analysts drawing things, click a button and it runs. It's really about bringing these kind of technologies, which really help, which solve a problem for developers into their world. And we're pretty successful with that. So we founded 2008 and we're basically a consulting company in the very beginning. But then we learned around the market and we pivoted towards being a vendor 2013. And that's where we are at the moment.
You make two orchestration engines that have different flavors. And I think one is related to event sourcing. So tell us about those two. And then I want to dive in and start talking about event sourcing.
We have what's called the Camunda VPN platform. That's kind of the workflow engine we do for over a decade, basically. So that means it's also designed in a way like you designed applications like 10, 15 years ago. You have a relational database and you have the workflow engine acting upon that, which is nice. I mean, there are a lot of advantages to that architecture. But over the time, we learned that this really limits scalability. And that means it blocks a couple of use cases where we see workflow automation can make sense. And actually, to be honest, I think I learned it the first time at a QCon where we had kind of a marketing banner at the booth where we said, I think it was scales like hell or something like that. And some guy from Google approached us and said, okay, that's interesting. How do you find scaling? And we explained a lot of things around that. And we were, I think, pretty proud of what we had because had a quite fast engine at that time. But he said, that's not scale. I mean, that's kind of, it always has a relational database. That's a limit. And we thought about that a lot. And actually, he's now CTO at our company. He thought about that very often. And he coded a lot of things in the night and said, how can we do that different? How can we do a workflow engine that really scales? And this is where event sourcing came into play, or event streaming, or whatever you want to call it. So you really do a completely different architecture of the workflow engine, basically in order to make it what we now would call cloud native, really scalable, really fault tolerant, resilient, and all these kind of things. And that's what we now released with CB. And it took us a while, 4 or 5 years now, to get it to a production ready state. But now we're moving towards production with a couple of customers.
Let's talk about when you say orchestration, walk me through a use case. Give me an example. Are we talking microservice orchestration? Are we talking email orchestration, kind of typical office kind of environments? What are we talking when we say orchestration?
The typical use case is really about what I would say microservice orchestration, but not like container orchestration. So a lot of people think of like Mesos or whatever, Kubernetes, if I say orchestration. It's more about, let's say, the workflow, the business perspective of
how they flow.
Right. So typical example I use in talks is something like order fulfillment, because a lot of people can relate to it. So you want to order something, and then you need a couple of services playing together in order to deliver it. Like you have to pay for it, you have to get it from stock, you have to send out notifications and these kind of things. And how you make a proper flow of these different microservices. This is basically what it's about. If you go like smaller, it could also be function orchestration. If you have a lot of serverless functions, you have to make them doing something useful and these kind of things. So that's the use cases I'm thinking of.
So that makes total sense then when we start talking about events. So let's talk about event sourcing and events. First off, just hit the basics. What's the difference between event sourcing and events?
I actually gave a talk at KubeCon about what I call the opportunities and pitfalls of event-driven utopia. And I also defined that in a way like also Chris Richardson did, or also there are a couple of readings for Martin Fowler. And I think it makes sense to distinguish between different things of what you mean with event-driven. And a lot of people are mixing that up. So one is very often referred to events on the inside. And that basically means you're building your one application in a way leveraging events. And that's very often around event sourcing. So you probably do persistence of your one application differently, very often in order to scale. And that's one thing. And the other thing is basically events on the outside. And that is about, I want to use events to communicate between different applications or services, for example, microservices. And that's where much more people actually referring to at the moment, because that's really what the whole microservice or event-driven architecture is very often about. But both can make sense, actually. And it's important to define what you're talking about.
So when you were talking about the two different types of orchestration, one being events and one being a relational database management system, and you talked about the limitations of the RDBMS, what were some of the limitations that you saw, that you started to see, that you started to smell, that event sourcing was able to really kind of fix?
It's really about basically throughput and scalability. So if you take the example of orchestrating microservices, it could be that you have something like, hey, I want to have a new telephone line or a new mobile phone. That's kind of an application workflow that runs probably a couple of thousand times per day, but not like a million times per second. But if you move to use cases where you say, hey, I want to do something, if you just make a phone call, or if you want to do this and that, then you have a totally different level of scalability required in the backend. Or in the financial sector, we're looking at trading use cases, for example. There you have a lot of throughput requirements. And this is hard to solve with a relational database if you run like millions of transactions per second. It's not totally undoable, but then you have to introduce sharding, for example, yourself. You have to throw a lot of money at the database in order to make it happen. It's always kind of a bummer to have that there. And this can be solved if you really re-architect the whole engine underneath.
There was a quote that you gave in that talk from Pat Heelan that said, grown-ups don't use distributed transactions.
Yeah, I love that. There's actually a different angle on that quote, because what I see a lot of use cases where you can apply that workflow orchestration engine to is around consistency and transaction management, because you don't have transactions in microservice architectures. So you have to solve the requirement of doing A and B in an all or nothing semantic very differently. And that can be a mini workflow, for example. The saga pattern is very often the thing people refer to.
As you were talking about, moving from a relational database management system to an event streamed system to an event-based system, the things that were kind of going in the back of my head were kind of how you changed your observability story. So you're not all kind of contained within a system. Now it's all spread out. So what did that look like and how did you address it?
That's the complexity of going event sourced. It's really changes the whole architecture. So for example, we can't query the core workflow engine anymore. We can't ask it, hey, what workflow instances are going on and how do I find that? And is anything stuck? So there are a couple of things we do on top of that. So first is we're creating some kind of projections, basically some snapshot state, which is kind of, what we had in the database before, but organized differently, and we could always reconstruct it. We use a very efficient key value store there in order to store that. So that's a very different architecture. And that's really optimized for the use cases we have. So we have to know the questions we want to ask in advance in order to design the key value store accordingly. So that's one part of the story. And then that's the whole, which is very often referred to as CQRS, like in order to read things, to really ask questions from the outside about the state, we basically export all the events to a separate store where we organize it in a way that you can ask questions again. In this case, we're using Elasticsearch for that. And there you can ask questions again, right? So all the operational tooling we have where you can see what's going on is based on Elasticsearch, with then also introducing like new problems, because that's kind of eventually consistent. So it might be milliseconds behind the real broker and these kind of things. So it's a much more complex ecosystem actually to think about. On the other hand, then you get the scalability you want. So that's kind of the trade-off you have to do actually.
Is it correct to say that Camunda is strongly consistent and ZB is eventually consistent? Is that correct?
No, not really. So Camunda in itself is always strongly consistent because it's always persists in the database. So we have transactions, all these kind of things. And when you look at the data, for example, from the operating tool, you look at that committed data. So you pretty much know what you're seeing. With CB, the core state in the workflow engine, that's not eventually consistent. So we do a lot of things around making sure that whenever you run something like in the workflow, whatever you say, hey, I did the task and now the workflow moves on, this operation, that's consistent always.
Has to be.
It has to be, right. That's what a workflow engine promises. The only thing that's eventually consistent is the operating view on that. So if you look as an operator into the system and say, hey, everything is healthy at the moment, that's great. It might be milliseconds ahead and you might miss an incident you get on like a millisecond later. That's the part which is eventually consistent, but you can live with that. That's normally not a constraint you have problems with.
What is that state store? What's that heart of it? How does that put together?
Basically, we're just having an event stream, which we write. So this is like start a new workflow instance. Okay, the workflow instance moves from A to B, it arrived at B, and so on and so forth. So that's a steady stream of events. And then first of all, we write that in a lock, an append-only lock locally. Then we replicate that. We use Raft replication for that. So we replicate that to the followers in order to make sure it's really persistent and it's replicated. So we are fail-safe in that way. If some cluster nodes are not available at that state, we might not be able to commit it. If we have like whatever geo-distributed systems, it might add latency. So there are a couple of drawbacks, but we make sure everything we execute is commit. And then we have that internal state. That's what I meant, what's in RocksDB. That's kind of a key value store thing where we basically check, hey, somebody wants to complete that activity in that workflow. Is that allowed at the moment? What's the current activity? What's the current state? We ask that to that snapshot in RocksDB locally, basically. And then we apply it on it. And then we write a couple of probably new events because then if we apply that, something else happens. So we write a couple of other events in the stream, which are then committed and so on and so forth. So that's more or less kind of the loop.
Yeah, very nice. You mentioned Raft. So you implement the Raft protocol to be able to keep these things in eventual consistency. Why did you choose Raft? Why not Paxos? What led you down that line?
That's a good question, actually. I wasn't involved in all of that discussion. But to my understanding is what the core team chose that because it was much easier to understand, much easier to reason about, and also that's much easier to implement. In the very beginning, we even implemented a version on our own. We moved away from that. We now incorporated Atomics, which is an open source library doing the same thing and contribute to that. But so far, from what I get, it's easier to understand and seems to be a good choice so far.
Is the solution, is it a kind of a SaaS solution or is it something that you run on premise on your own cloud environment?
So at the moment, it's an open source project. You basically can run that yourself on-prem. That's what we have at the moment. We are also building out a SaaS offering at the moment. So we are not yet there. We are in a closed beta state. So we do that with a couple of customers. And to be honest, like myself, I truly believe that will be like the future way of really providing it because we are seeing a lot of people moving to the cloud. But at the moment, it's an on-prem thing. You just download it probably with a Docker environment or whatever and just give it a go. We have a lot of get started guides around running it in Kubernetes. So that's kind of the environment we target at the moment.
Let's switch a bit and talk about CQRS. You mentioned it once before. CQRS was kind of popularized by Bertrand Meyer in object-oriented software construction, and then later on by Greg Young. At the most basic level, kind of segments reads from writes, so that way you can scale kind of independently for the two. Tell me again a bit about how you all implemented CQRS. Was it custom implementation? Was it frameworks? What did all that look like?
For us, it's more or less the concept we used. So we didn't use any framework around that. For us, it basically means within CB that we have that event stream and you can easily connect to that. So if you want to do something with it, you connect to the event stream. And we do that by one exporter. We call that exporter, which just writes everything to Elasticsearch in a way that makes sense for other consumers. And then we base the reading part on top of that. It's not a pure CQRS thing because even within the broker, we do reading, but in a very different way. That part is more like the operating use cases look at it. But it's kind of the concept. We separate the query from the runtime side. And we had to do that because we couldn't ask the runtime anything. So we had to do something about it. It's actually not very easy to apply, to be honest. So I think a lot of people currently struggle with doing that, or struggle with the implications of having now eventual consistent read and these kind of things.
What is the relationship between CQRS and event sourcing? Is there a direct relationship?
From my perspective, it doesn't have to be. But I mean, if you do event sourcing, then you probably need CQRS in order to do certain reads. Not necessarily, but you normally have that because the event sourcing gives you not necessarily all the querying parts. So that's my take on that at the moment.
A lot of times when people talk about CQRS, they also talk about domain-driven design. Is there a relationship between the two? Did you discover a relationship between the two?
I think there's no clear relationship, but a lot of the discussions we currently see are triggered in a way by domain-driven design, or let's say by a gained popularity of domain-driven design ideas. So I find domain-driven design very interesting, and it facilitates a lot of good ideas in other communities. If I look at the microservice community, they currently apply a lot of the ideas of DDD, and then on a broad range. And I think it's the same for us. A lot of the things you see in DDD, or at least in the DDD community, might also facilitate using CQRS with the same success as things in the microservice community.
Let's talk about the relationship between commands, query, and events. What are the distinctions and where do you draw the boundaries?
That's actually, I think, one of the key questions a lot of people should really understand at the moment. It's kind of a boring question to discuss terms like what's the difference between a command and event.
And language matters though, right?
It does very much actually, especially with tools like, for example, Apache Kafka coming up. And they very often talk about event-driven things. And then a lot of people are basically thinking about it and say, okay, there's an event on Kafka. But that's actually not correct. On Kafka, you put records. And there's a good reason why it's a record and not an event. Because a record still can be an event, a query, or a command, or a message in a messaging system. The content of it could be a command, an event, or a query. So basically you have all three of them. But a lot of people mix that up at the moment because they think what I put on Kafka is an event. But that's not true. And from my perspective, it's important to distinguish especially commands and events. So whenever you have, for example, let's take two microservices, and there's one way of coupling them where you say, microservice A say, hey, do something for me, send out an email, or book out some goods I need for that order, or retrieve the payment for me. That's clearly a command. And the other way around is like an event-driven coupling where you say, hey, somebody has ordered something. So the other microservice could react on that. And at the moment, I see a lot of people believing that these react on that. The event-driven approach is the only way of doing a decoupled system. And I don't believe that's true. I actually believe it's totally wrong. And it leads us in a very, very bad direction. So depending on the communication, depending on what I want to do there with the two microservices, either commands or events could be better. There's not like, this is the rule you have to apply. You have to think about the communication. And where do you want to couple, in the sender or in the receiver? And it could be like retrieve payment, for example. It makes much more sense that you send a command because otherwise you have a payment service which has to know of each and every of its users because they might emit events where he has to react on. That's not a very good architecture. On the other hand, if you, for example, say you want to send out notifications whenever something in your order happens, then it might be good to write a service that just reacts on certain events within that order and set out the notification, because then you don't have to think about where to put that logic in all of your services. So there are use cases for both, but you have to think about that and you have to understand the difference.
Is that in just how you react to the event that's going across, or is that actually in the shape and the structure of the data that's on Kafka, for example?
It might change the data you have in that record.
The state of it?
Not really the state, but what you put in there, like what data you put in there. It's kind of an interface between two services. So let's assume you have Apache Kafka there and you want to send out like an event. That means the sender exactly knows what's the event name and what data it puts into that. And the recipient can choose from that. And if you provide a command, it's the other way around. The recipient can define, hey, this is a command I understand, and that's the data you can send me. I mean, it's the same thing, but it's really who defines the interface, who defines what data is sent around, and that determines very much how easy you can change it later on.
One of the other things when we were talking about right before was this balance between choreography and orchestration. What does that mean?
If we're sending commands around, if one service commands the other, that's referred to as orchestration because I orchestrate somebody else. Hey, do that for me. If it's event-driven, it's choreography. That basically means I react, and everybody, just like an orchestra, just reacts on events and does something, and it works. And what I said earlier on, it depends on the communication at hand if commands or events make more sense. And that means both have its place. And for me, that means I have choreography and orchestration in every system. And I should balance them. And I always think of like I have these orchestration and choreography as a pillar, and then I have kind of a platform on top of it. And all my services are kind of small balls sitting on top of that. And as soon as some of the pillars is not like high enough, I get kind of a decline or an incline, and all the balls are like rolling out of that platform. And then I normally draw two buckets, and that's either the chaos bucket. So if you have not enough orchestration, it's normally the chaos bucket. Or if you have too much orchestration, it might be the monolith bucket. And you have to be aware of just being in the middle. And that's quite hard. And it's counterintuitive to what most people have in their minds. So when I currently join discussions, it's very often we go all orchestration. That's the thing. We have to use workflow and BPM and all that thing. Or people are, no, we did that 10 years back. It didn't work. We have to use choreography in order to get a decoupled system. And it seems to be like this, like either I'm here or there. And I very much believe, like always, more or less, you have to be somewhere in the middle. And that's something people should find out. What's the sweet spot for their architecture, for their system? And it's somewhere in the middle.
So what's next for Camunda?
So we're doing a couple of things there. First of all, I mean, we have a very successful platform out there. So we will continue with doing that and continue globalized efforts in order to get more customers on board. That's the one thing. But like technology wise, we just released CB in a production stable release. So we're currently putting that into production with a lot of new customers. We see a lot of new use cases, and I'm actually quite curious to see how that goes. We still have to learn a lot of things around there and to validate a lot of things around there. But that's pretty exciting. So far, it's really good. And then with that, we want to unlock a lot of new use cases around workflow automation with the scalability thing. And the second thing is to make it easily available. I mean, that's like introducing a cloud offering. That's also quite a challenge at the moment, but also quite exciting. And that's kind of the orchestration part. And what we also introduce, and I find that very exciting as well, actually. So we started doing basically a proof of concept around what we call process event monitoring. Either you go only with choreography, event-driven things, then you still want to see what your workflow is doing. You want to understand the business process. That's kind of around monitoring, for example. There are some solutions out there, but none of them really focusing on the business process, on the business aspect of that. And we are currently doing that in a way that we can discover the ongoing business process, and then we can leverage all the tooling we already have. So we have a lot of tooling around analyzing it, showing a lot of heat maps, understanding like bottlenecks or understanding if SLAs are hit and these kind of things. And we want to apply that to workflows which are not running in our engine too. That's what we're currently doing. And that has a second chapter to that, where you might want to see like the end-to-end workflow, which is normally never automated, like fully in our workflow engine. You always have parts which are playing ping pong here and there. And we want to extend the view so we can really see the end-to-end workflow as well.
We touched on this just a little bit before with some observability. So do you instrument like tracing so that way you can trace as it's moving throughout the system?
Not really. So, I mean, most customers which have these systems, they already have tracing. So they have something in place. And we did some experience with adding workflow to the traces. So we have some customer using Zipkin, and there you can see like the whole workflow as one trace. So there are a couple of ways of doing that. But that's actually not where we want to aim at. I mean, that's already there. And there's a good use case for that. But we base typically on the events. If you're using things like Kafka or messaging, it's normally very easy just to copy all the events to your own system and make sense out of that. If you do something else, it's harder to get the events. But if we get them, we can reason about them. But that's normally not a very technical, I called this method, I sent this message. It's more like, hey, some real domain event happened here, and we want to make sense of that. So you bring it more to the business level. That's what we're trying to do there.
All right, Bernd, thanks for joining us on the InfoQ podcast.
Thank you very much.